But I am working on so much stuff. I could be here every month if you guys wanted to listen to me that much. How many of you have worked with OpenCV? Oh, be careful. And how many are interested in OpenCV and haven't yet? Okay, so my original idea was how to get started OpenCV, very hands-on, everything you need to do. And after working on that for a day, I realized it wasn't a full semester class I was doing.
What is OpenCV?
Oh, well, I'm going to hit that. That is just a perfect question. So what I'm going to be talking about is kind of in between what is OpenCV, where does it fit into the universe, and how to deal with it in Python so you can get started on it when you go home. Okay, so again, what are we talking about? What is OpenCV? What can you do with it specifically? And that can be kind of, I have known about the product ever since Intel started it to show off how cool the 8286 and their C compiler was. And I ignored it for most of the intervening 15 years, partially because I didn't have an application, and partially, you know, I don't do compile, link, and wait 15 minutes. You know, and OpenCV is changing a lot. There was like a 15-year period when it was at 1 point whatever, and then 2 point something, and it is now changing almost by the hour, and is getting to be really, really interesting. And then I will go over some practical orientation on how to get started using it, which anybody can do, and it's easier if you've got a MacBook. You know, why am I here at all? You know, because there was a request for organizers, and request for volunteers, and I was the first one to get in, I think. I've always been interested in programs that make things move. So that has had me involved in robotics sorts of things for a long time ago. The first one, my first big project, I didn't realize was a robot. It was a machine that was about 75 feet long and took checks and moved them down about 50 miles an hour and sorted them into all sorts of pockets so they could go off to other banks. When you know, it was a check sorting machine, but it was a pretty amazing robot. And I have spent a lot of the last 15 years helping engineering students and professors on their robot projects without doing any myself. Last year I stumbled into this meetup DIY robocars that is building autonomous cars, but at small scale. So their $200 is kind of the starting car unit that the people are building, you know, which is much less than what Google puts into their cars, for instance. And when there are accidents, nobody dies. So, and you know, that got me building for my own and got me into vision, real hands-on. So I'm trying to share what I've learned over the last year and a half. Also, you know, kind of eating into my break time, I am actually looking for employment. I've tried a little bit, you know, if you want to put me through the gauntlet of the Google hiring type process and throw me into a bank of cubicles, I'm probably not a good fit. But I can do interesting things. You know, as far as my, you know, bona fides in robotics, I've been electronic hobby since the early 60s. I've been a programmer since the late 60s. Started doing real-time systems in the 70s. Bumped into Unix around System 3, I think. You know, started networking at about 100 baud. First IBM PC to arrive in San Francisco was hand-carried from IBM's office to my desk. Microcontrollers, PIC processor, whatever. And I've been with Python, can't remember if it was 1.3, 1.6, but been doing that for a while. Okay, what is OpenCV? Could you get me a water? I'm not going to make it through here. I've got too many slides, so I'm going to go really fast. Okay, OpenCV is an open source computer vision and machine learning software library, which tells you nothing. That is directly from the About page on the project. And that is one of the challenges with OpenCV. You know, lots of trees, no forest. it's hard to understand how to get started. Until recently, its main function was to take a bunch of pixels and try and find things in it. Something that's a big color or big shape. Thank you. It is now progressing quickly beyond that to plug into this deep learning world that seems to be running everything and occasionally running into freeway barriers and whatnot. Okay, when do you use OpenCV? Its core functions are looking for discrete shapes, looking for the red blob, looking for the rectangle among the squares or among the circles. That old core stuff works best when you know what you're looking for and you just want to find that, and when you're in an environment with limited ambiguity. It is also extremely useful, deep learning people think about this, when you need auditability. If an OpenCV car ran into a freeway barrier, you could explain exactly what went wrong and what we need to fix. Deep learning says, oh, we just need more data. We need more testing. And because, but you can't, on the other hand, Audacity has a self-driving car that they've driven up the entire El Camino from San Jose to San Francisco, and it had something like a 99% reliability of identifying the traffic lights along El Camino. You can't get there with OpenCV. They're really complementary architectures. General issues with OpenCV. If you've ever looked at it, didn't understand it, it's because it doesn't make any sense. It is not a thing. It is just a whole bunch of stuff thrown together, all having to do with vision, obviously, but not very well tied together in any other way. It is now changing extremely rapidly. If you go to their website now, there are like 2, 3 future versions mapped out. They went for like 5, 6 years without any real releases at all. And now they're just changing like crazy, and it's very exciting. It is still stone soup. Somebody invents that, they write some code, it goes into OpenCV, and without a lot of help. The code is open. You do have to be a little cautious. There are some patents on some of the processes. For a while, NVIDIA was not doing OpenCV, but they have now relented because it's like Python itself. OpenCV is just moving out to the world. If you want to know what things are really doing, you're going to end up reading a lot of research paper. There is nobody getting paid to write nice developer documentation. You go back to somebody's PhD research paper. And there are new design patterns evolving. This combination of the OpenCV, the vision systems, and deep learning. A year ago, it was which are we going to do? It was deep learning or vision. It's now turning into an and I actually have a demo of that. Just odds and ends. If you've heard really awful things that's unusable, whatnot, that is all old. And OpenCV is actually kind of easy to use once you get past the math. It is now a native Python system. The core libraries are obviously C, C++, but the interfaces are all Python. The image, OpenCV image is a NumPy matrix. You want to use the latest stuff, which I'm working with 3.4. Part of the reason my robot isn't here is because everything is going to Stretch and Python 3.7 and OpenCV 3.4.
So does your robot, you said Stretch, so does your robot run on Raspbian?
Yes. Yeah, I've got a whole library of Python code, and all of it runs seamlessly back and forth between OS X and Raspbian, thanks to Python. If you go Google, you have a question about OpenPython, Google finds you stuff, half the time it's on Stack Exchange. It used to be, a year ago, it was a huge problem that every discussion was about C++ and OpenCV 2 dot whatever, which nobody's saying uses. You want to be using OpenCV 3, and it is very, very different. Just a little oddness, we all know RGB for color mapping. For whatever reason, the default and baseline in OpenCV is BGR, same colors, different order, and live with it. And of course, sometimes they do use RGB just to keep life interesting. Documentation extremely terse. You will either be following other people's patterns or reading research papers. Probably not very readable, but this is OpenCV documentation, much like my presentation. For this, you can go through all of this stuff about this vision system and not see a single picture. But you'll see lots of functions, lots of math. I've got a son who can look at that and know what it does. I have to grunt my way through it. But you have to be willing to do that. It's all about the math. How am I doing on time?
Good.
I've got a ways to go. Okay, the general use pattern, nowhere will you find real explanations of all of this. You'll see this is how to do this. And they don't really explain why they're doing that. They're just saying, do this, do this, do this, do this. Copy the code. The general pattern when you are processing OpenCV is you grab an image. Okay, we are always operating on a single still image that may have been grabbed from the stream of a movie or USB camera or whatever, but we are dealing with one image at a time in OpenCV. We generally, the first thing we try and do is crop it to bring it down to a manageable size. That is called the ROI, not return on investment, but region of interest. If you're a vision person, ROI is region of interest, and it's just saying there are too many pixels in this image to process fast enough, especially on my Raspberry Pi. We then fiddle with it with the intent of making the edges more sharply delineated. This is the problem with image processing, especially in the real world. As a human, I look out there, I easily see the individuals. I look at the chair, they're all white, and I take a picture, and suddenly that white chair is actually a little bit blue right now because the guy in front's wearing a blue shirt and the light reflects that way. My eye system just erases that, the camera captures it. And creates all sorts of problems. So we want to try and make the edges sharp. And once we have edges, we can then try and find objects. And then, generally, we're going to output data. Where the orange ball was, or where the lines go, or sometimes we want to annotate the image for humans. This is code-ish, okay? All we have to do to get an image is read it. Generally it's going to be a JPEG file. That creates a NumPy array, a matrix. Remember that. Terribly important. So you can deal with it any way, either OpenCV or with NumPy. The array is by row and column, which is Y and X. Drives me crazy, okay? But you have to remember that, again, for the array, which you're going to deal with. The third element is the value. The value can be either a scalar. If it's a gray, if it's a black and white image, it's just going to be a number from 0 to 255, which represents, the brightness of that pixel. If it's an array, it's actually a matrix of 3 elements, say your RGB values. Well, that creates a headache because when you ask for shape, sometimes it'll be a 2-element tuple, sometimes it's 3, and so you have to do all of that stuff. Okay, the value when it's a color image is just 3 integers. Okay, and OpenCV does not keep track of that. When you read in a JPEG, it's going to be BGR, and you can convert that in various different ways. And if you change it to YML or HML, it changes the values for you, but it doesn't remember that it's not BGR anymore. So you get these ugly things if you write them out as a JPEG. So we crop. A crop is just a Python slice. One thing terribly to remember when you know, the efficiency of Python, that is a view because it's a NumPy slice. And if you then change that, you're changing your original picture, which sometimes you don't want to do. So often you'll throw a copy on there to make a copy. Again, region of interest, remember, ROI. And that's just cropping for us humans. Color space. Okay, you know, we're back from the VGA days, pre-color days. You know, it's 3 elements. You know, the native, when you read a JPEG in, it's going to be in BGR. 3 integers, 0 to 255 each, the intensity of the red, or blue, green, and red. There are other color spaces. You know, the one I'm using the most these days is HSV, and I've got the picture here. One of the problems with BGR is, okay, I want to find the red something or other. You know, well, that means I want lots of red, and, you know, but some of the others is okay, but, you know, and if I want whitish, I want 3 values that are about equal. It can be kind of hard to deal with. You can see with the map here with the HSV, we map the hue now as we can just ask for hue. If we want a deep red, we can just say, I want red, and, you know, ignore some of the other things. So it can be easier for the human to specify the colors. It's a straightforward mapping back and forth. It doesn't really change the amount of work that has to be done. But it can be easier for you to set things up. Once we get that image in, we then, you know, we crop it. We then want to do things to distinguish the elements we're looking for. And, you know, if you look in the documentation, look for blur, dilate, erode, equalize, just different techniques for getting rid of noise from the images. You know, there's masking, you know, again, it's mainly having to do with colors. Okay, and our goal is to end up with an image file that has a high level of contrast around the elements that we want to identify. And then we need to find the object. You know, canny, you know, another fun thing with OpenCV, you know, why is that function called canny? Is it because it identifies edges, you know, with, you know, canny ability? No, because it was developed by a mathematician named Robert Canny. You know, and same with, you know, Howe lines, Professor Howe. So Canny finds edges. Howe lines can look at groups of edges and make them into more useful lines, longer lines, basically. Contours looks for shapes, and it gives you this complex hierarchy of different shapes, you know, because if you've got shadows, you have shapes within shapes within shapes. You can explore, you know, the data structures you get back are poorly, if at all, documented, but it's Python, so you can find everything you need to know about it thanks to Python. Okay, and there's a whole bunch of other stuff out there. But, you know, if you look at 100 examples, 98% of them are going to be using these few functions I've mentioned. This is an example input and output of what OpenCV traditionally has done best. We've got some objects, and it created an outline and put a dot in at the center of mass. This works extremely well. Because it's high contrast, continuous edges. You know, in the real world, there are also you know, when you're doing like freeway line following, there are just all sorts of discontinuities and color permutations you have to deal with. Yeah, so basically I just said that. Okay, when you are playing with all this, you can't trust your eyes, you can't hardly trust OpenCV, you basically can't trust your intuition. OpenCV itself, you run it, perfect function, you know, it's read one file, it's created another file, the data is great, what does it look like? You bring it up, your eyes are interpreting that in various ways. Your operating system does things for you to help you, especially under, this is the only thing that's bad on OS X. Mac, you know, Apple helps you more than others. So this is actually a pure white box with a piece of 3M blue tape on it. In a room that was, you know, living room pretty well lit up to my eyeballs. But I was playing around with ISO settings on my camera, and it comes out all sorts of different ways. The black box is what OS X kindly did for me, because it thought, well, I don't know exactly why, but it didn't think I needed to see the data that was there, because I think poor contrast. I went through a contrast enhancement function, and it pulled that second, you know, the fourth picture out of the third. You know, the data is what matters, not what it looks like to your eye. Yeah. Okay, there are all sorts of other things out here. This is one that people want to use, warp perspective. This is the original picture from my robot. I was centered in this lane, or I was in this lane. And over here, you can hardly see it in the original, is the lane where we wrap around. Warp perspective straightens all of that out, makes, gets rid of the perspective that's in the original photograph, so you can tell which lines are straight, among other things. And I just mentioned that just to say that there's just a million things in OpenCV. The latest stuff coming out is this cooperation between the deep learning and OpenCV camps. I'm going to do two things here, hopefully. So I'm going to run some code. So this is an old movie, Charlie Chaplin. In the code was a bootstrap marking a box around Charlie Chaplin. The deep learning portion just knows how to identify humans, doesn't know anything specifically about Charlie Chaplin. And it also knows about movement patterns. So what is happening now is OpenCV is managing the process. It is actually running the convolution network. Okay, finish, that's all there was to it, which was doing two things. It was projecting where the image was probably going to be next time, as well as identifying whether or not it had found what it was looking for. So instead of looking at this huge image and trying to find the human on it, and which one, we start out knowing, okay, there's a human here, but the human might move, and the network is predicting where it's likely to move to, so we know where to set our region of interest, so we don't have to process the whole thing, and then verifies that it's actually there. I don't think it has error logic. It's one of the things I'm currently working on in my world, if you don't find it, then what? If you're going down the freeway at 60 miles an hour and lose the lane, you don't want to do, sys.exit1. You need to do something else. That's interesting. Oh, That's why I'm running a PDF. Okay. And then another place, sorry about that. Oh. I didn't see a network I can, oh, yeah, it's too bad. Okay, one of the things that's nice, so imagine you've got a pool table, you split the rack, and the balls go all over. OpenCV is really, I want to find all the balls on the table through every frame of this picture. OpenCV would be really good at every frame finding those round balls on the pool table. It's almost a perfect application. Now you say, well, I want to keep track of which ball is going where. OpenCV fails. It can find the balls in each frame, but it doesn't know which one is which from frame to frame. With this tracking API, which we kind of saw in the Charlie Chaplin, it now can track each ball as it moves through. Okay. Other things you have, you can, if you have an image, a matrix, you can write it out as a file. So if you've modified, you can capture that. You can make movies, all sorts of cool stuff. If you want to do any of this stuff, the easiest thing is buy a Mac, install Homebrew, install OpenCV and Python, and you've got everything, up to date as of like 2 weeks ago. Windows, actually, I have no idea. I haven't done development on Windows in a few decades, but there seems to be pre-built libraries for Windows, which gives you one good thing is Linux distributions are back on OpenCV 2. Whatever, so you're going to download the source and compile. On my MacBook, that takes about an hour. On a Raspberry Pi, it takes about 2 hours. But there are lots of instructions how to do it, and you get to watch TV while that's going on. So I probably went longer than I should have, but any questions? How are we doing?
Let's see. Yes, you do, because it works.
Hi. So can you do rudimentary self-driving car without having binocular vision, or can you just use a single camera on a Raspberry Pi?
I don't know of anybody who's using binocular vision.
You don't run LiDAR on those little things these days?
Well, LiDAR is not binocular. LiDAR is a single point of light.
It's one all-seeing eye. That's the idea.
I actually was blind in one eye for a couple days and didn't notice it. There are times you use that, but it's really not, we deal with perspective, and an intuition about perspective really is how we as humans do most of our depth perception. If on a camera, my robot actually has a camera on a tilt pin, and I was thinking of, putting on a Z-axis that, it can tilt around. You see that birds have this problem because they have eyes pointing out in different directions, and when they need it, they just move their neck around. But at any rate, stereo vision is not important and doesn't work all that great. And I'm guessing it's not going to be part of the stack for self-driving cars, my guess.
Yeah. 2 eyes, it's mostly about redundancy. I think as engineers we can appreciate. Question here.
I'm wondering what makes it like auditable. It's like purely analytical.
Yeah, I mean,
to canny and how.
There are published functions, for a given set of inputs. There are functions that derive to exactly what it does. It's repeatable, it's modified. When something goes wrong, I go to a lot of robot competitions, and I'm the ass who, whenever a robot goes off the track, what went wrong? How are you going to fix that? Mine goes off the tracks all the time, but it's getting better in knowable ways. The the guys who are, the donkey car guys, deep learning, or just needs more training. And I don't think there's enough training because you can't train it for all of the outputs that you care about for complex situations.
Yeah, I think it's the determinism and the like well-studied aspects, but still, I think I prefer both approaches where possible.
Yep.
Belt and suspenders, especially when neither of them is fully cinched. All right. More questions? Cameron, blue shirt guy.
Maybe this is naive, but is it possible to apply these algorithms to a 3D image?
Sure. I mean, they're all 3D images, right? There's a challenge knowing what's, to a certain, when you look at this image, you geometry a robot. I could pretty much do a model of the ground because I know where it starts. I know the diminishing factor. The truck is there in 3D space. As humans, we have no trouble identifying either that it's a truck or about how far away it is. It's with any of these systems. The systems have trouble separating the truck from the trailer that's behind it.
It could be a billboard, could be something. I mean, only one way to test it is like you gotta go straight through it, full speed.
Exactly, full speed, and the distance, for the lines, especially the dashed line. I know those dashes are approximately equal size. I've got all sorts of factors that I can pretty easily program in to figure out where that truck is really challenging, but the way you get there, which I don't know anybody's really, maybe Google, but they don't talk about it, but looking at several frames, I know how, if I've got encoders, which is one of the things, part of the reason the robot's not here, I'm working on the encoders. If I know how much the camera has moved, I'm starting to get enough information that if I can identify the truck as an object, which is a non-trivial thing, that based on how much it's changed as I move this far, I can get a and knowing how big pickup trucks are, I'm starting to have enough information to figure out where that is in 3D space. It's going to be an integrated, a lot of the management OpenCV is a tool. To know it's a truck, if that were a car on the freeway, I probably have enough time to send that to Google, have Google tell me that it's a truck, and then I can start applying this OpenCV following to keep track of where it is, how its size is changing, because that's giving me the size of the bounding box. I can see how that's growing. The advantage, one of the things you have to remember, people get all caught up in, these milliseconds of freeway. The reality is something 1 second in front of your vehicle at 70 miles an hour is dead, okay? You don't really need to analyze it. Just to keep everybody else happy, you probably want to slam on the brakes, but that's really not going to help that person. You have to be looking far ahead and making your decisions far ahead because you can't turn that fast. And you have to make sure you're not turning into, you don't want to save that one person by turning over and driving a school bus over the cliff, which involves recognizing cliffs and school buses. And, it's just, there's this huge world that you have to think about for these systems to really work in the current world.
Sure. I mean, it's the trolley problem, right? I think every self-driving car should just in the future ship with one lever that just decides whether or not to hit a school bus. Okay. All right, one last question here, and then we'll just take it offline.
Speak loud. One very practical question asked me driving back home. A lot of models coming out this year have lane assistance, just like your picture there. are they truly look at the white lines, or what if there's a piece of wood on the middle of the road? Are they going to shape that car?
The question was about lane, like sort of vision assistance.
Yeah, I mean, they are just looking at the line. They're looking at fairly limited view ahead. They're just looking a few feet ahead, and there's less less can go wrong within that field of view, and you're looking at it continuously. So if you're following the line and the line disappears, because there's a piece of wood on it, it shouldn't react to that, because it's not looking, it's where the donkey car goes wrong. It's looking at the universe and trying to find the line. That's not the way you or I drive. We look at where we expect the line and make sure it's there. And if it's not there, we then start to do a secondary analysis. What is wrong? But also before you engage that, there's like a 15-page release of liability that you're supposed to be reading on your car screen. But that is a fairly simple problem. Am I wandering off from the lane? That is nothing like autonomous vehicle.
I mean, the car is going to have this existential thing. Where did I go wrong? What am I doing? Driving. All right. It's a very, very interesting existence. All right, Al. Thank you so much.